Welcome to this video on energy audit and management. The objective of this small video is to get your concepts clear on energy economics. It's a very interesting course, especially the subject of energy economics is often very interesting for the students doing this course on energy audit and management. Why is that so? The reason is simple, because when you are technical part of energy audit and management, we are interested in saving the energy. The energy saved when you are presenting it before, after, let us say, after doing an audit of some industry, we come out with a savings that so many units of electricity can be saved, or so much of the furnace oil could be saved, or so much of the coal could be saved, whatever. So that saving, if we are able to explain in terms of money, then that becomes more convincing to the policymakers of that industry. Because when you are, as an energy auditor, when you are making a presentation after you complete the audit, because generally the audit procedure is what? We conduct the audit, and after the audit is conducted and our analysis is done, we make a presentation before the policymakers and convince them that this, if you go by this route, you can save so much of energy. But if you are able to convey that energy savings in terms of some concepts of energy economics, that becomes more convincing. So the objective of learning financial terms or economic terms is to equip us as auditors or as students with the concepts which are generally used in energy economics. So what are those concepts? So I had listed 5 of them. You can read those in the slide. One is the concept of simple payback period. There is the concept of return on investment, or ROI. Then there is a concept of present value and net present value, which essentially has to do with the time value of money. What is time value of money? I'll shortly explain. And then finally, an interesting concept of internal rate of return, or IRR. So all these concepts, generally the students who do a commerce course, they are equipped with all these concepts. The advantage of learning these concepts for engineers is we would be then be equipped with both the technical knowledge as well as the economical aspects of it. So what is simple payback period? Simple payback period, if I want to explain it with an example, okay, I'll give you a very simple example. Let us say that you have done an energy audit and you are saying that a bulb, incandescent bulb, a filament bulb I mean to say, needs to be replaced with a LED. Okay. And this is what you are proposing as an energy auditor. And for that, let us say that some investment is required. Let us say that investment is rupees 200, which is the cost of LED, let us say. Okay. And because you are replacing this bulb with an LED, you would be saving certain electricity. So you would have certain annual savings. Let us say you would have certain annual savings, and that annual savings, if you, let us say, have it in terms of money, okay, express it in terms of money, let us say that annual savings come to about 50 rupees. Okay. So why is this saving happening? This saving is happening because you are saving electricity, and because you are saving electricity, your energy bill would be, electricity bill would be less. Okay. And let us say that less bill, okay, that amounts to rupees 50, okay, by replacing one bulb. Okay. Now, if you know this, then what is simple payback period? Okay. So the simple payback period, I'll call it as SPP, is the time required It is the time required for recovering this investment. Okay, now how many years would be required for recovering this investment? So in order to calculate that, the number of years required to recover this investment, okay, it can be calculated by a simple expression, which is the investment which has gone upon, that is expenditure, capital cost, upon the annual savings. So the units of both the numerator and denominator would be rupees. So in my example now, which I had taken, this obviously becomes 4. Okay, and the unit of this would be, because the denominator is annual savings, so you would have 4 years. 4 years. So the simple payback period happens to be 4 years, right? And you see, as the name indicates, it is extremely simple to calculate a simple payback period, right? Now, what is the advantage of calculating a simple payback period? You are suggesting an energy audit option. The advantage is pretty obvious, that if you want to convince the management about the energy saving option, for example, if you are saying that you replace a bulb with LED, then this calculations becomes pretty simple and straightforward, right? So this is an advantage of simple payback period calculation. You can do the calculations very easily, right? Now, what is the disadvantage of this? The disadvantage is that this, for example, it's too simple in the sense that it is based on number of assumptions. Now, what are the assumptions? For example, in this case, we are not considering the life of the bulb and the life of LED, life of the bulb and life of LED. So now, why is this disadvantage? This is the disadvantage because we are not calculating the savings over the entire. We are not calculating the savings over the entire life of that energy saving option. So that is called as life cycle costing. So the disadvantage is that you are not considering life cycle savings, or we are not using the life cycle analysis for calculating the simple payback period. And this is a very important disadvantage. Okay. The second disadvantage is that it does not consider what is called as a time value of money. Now, what is the time value of money? I will explain shortly. So what are the two disadvantages? One is that it does not consider the life cycle savings, and second is that it does not consider the time value of money. This is a very interesting concept, time value of money. So what is this time value of money? Okay, in order to understand what is this time value of money, let me draw a time graph. Okay, time graph means, let us say that I am here. So this is today. This is today. Okay. So let us say today I am lending 1,000 rupees to my friend. Okay, this 1,000 rupees is given to my friend. Okay, and this friend, let us say, after 10 years, and he's a very good friend of mine, he gives me back 1,000 rupees. Okay, he pays me back 1,000 rupees, right? So what would we say? We will say that, okay, so this is a very good friend of yours. He has returned your money. Okay, the entire amount he has returned to you, right? However, if you look at it from the, forget about the friendship, but if you look at it from the economic perspective, what you would understand is that your friend, the friend has borrowed 1,000 rupees, and actually this friend of yours, okay, or friend of mine, has actually returned less than 1,000 rupees in today's value. Why is that so? It is because in English you have a proverb. What is a proverb? A bird in hand is worth cuckoo in a bush. What was the meaning of this? The meaning is that the value which is we are having today, okay, that is much more precious than whatever you are going to get in the future. But the reason is because that 1,000 rupees is going to buy me less and less quantity of goods, okay, as you move towards this side. So in the future, the value would be less, okay. The value of this 1,000 rupees, whatever the value is today of this 1,000 rupees, in the future this value is going to be less. So in order to know how much is the value in the future, we use the concept called as discount rate. So what is discount rate? So we need to understand at what rate this value is reducing. Okay, so if you know the rate at which the value is reducing, we know its discount rate. Okay, so what is the concept of time value of money? Time value of money tells you that the value of the money which is available today is much more than the value, same quantity of money, okay, which you are going to receive in the future. Okay, and how do you do the calculations then? How do you account for this time value of money? By putting a discount rate. Okay, it means what now? Let me again take some example. So to explain you again this, so let us take again an example of the some investment. Okay, so let us say that you are investing something. Let us say you are investing in an LED. Same example I'll take. And in your earlier case, we said that there is some saving after 1 year. So let us say that after 1 year you are getting 50 rupees. You are invested 200 rupees. After second year, again you are getting 50 rupees. Third year, again you are getting 50 rupees. And fourth year, you are getting 50 rupees. So simple payback period, you say that is 4 years. Year 1, year 2, year 3, year 4. In these 4 years, your money is recovered. However, what we are saying is that using the time value of money, this 50 is not actually 50, it is less than that. How much is it? This 50 is actually 50 upon 1 plus D. Okay. This 50 is much more less than this 50. How much is that? This 50 is 1 plus D raised to square. Okay, this 50 is again much less than this 50. So how much is this 50? This 50 is 1 plus D raised to Q. And similarly, this 50 will be 1 plus D raised to 4. It means that the present value of this 50 is not 50 rupees. The present value of this is how much? This present value of this 50 is 50 upon 1 plus D. The present value of this 50 is 50 upon 1 plus D square. The present value of this 50 is 50 upon 1 plus D cube, so on. Okay, it means that you are not actually receiving 100 rupees, 200 rupees. So how much are we receiving? The savings would be, the present value would be the summation of all this, okay, right? So summation of whatever you are getting, the annual returns upon 1 plus D raised to n. Okay, so this is the present value. About the concept. So what is the present value? So present value is the value of the returns which we are going to get, okay, as computed today. So the 50 rupees which you are getting after 1 year is actually less today, and that value is 50 upon 1 plus D. The 50 rupees which you are going to get after 2 years, it is less valuable, and what is its present value? Its present value is 50 upon 1 square. So the summation of all this is the present value of this, and you will find that if you do the calculation, you find that this would be less than 200. Okay, so this is the concept of present value. Now, what is net present value? Okay, so in order to calculate the net present value, okay, I had taken the example of LED bulb again. So we have invested 200 rupees. So that invested amount is, let us say, C naught. So naught is for 0th year. Okay, 0th time. In 0th year, you are making C is a capital investment, and that is 200 rupees, let us say, for the LED bulb. And the present value of this, in my example, I had taken this. Okay, so this value I had calculated. This value I had calculated. This value I had calculated in today's worth. This value I had calculated in today's worth. So this becomes my present value. Okay, so now what is net present value? So net present value would be the difference between the initial investment and the present value. Okay, so what is net present value? It is the difference between the initial investment and the present value. So you see that, so there is a difference, okay, initial investment and the present value. Now it depends upon how you are defining it, okay, whether it is C naught minus PV or PV minus C naught, right? Now, if you are having present value as positive, okay, what is the meaning of this? And the present value, okay, I will just define it the other way. I'll call it as PV minus naught, C naught. So the NPV is greater than 0, net present value is greater than 0. So what is the meaning of this? Meaning is the present value of the savings, okay, which you are going to get is greater than the investment you have put. So which is good. Which is good. Right? But if you are getting the net present value is negative, it means what? Whatever investment you have put, okay, so that investment is not recovered. So this is not desirable. Not desirable. So what is desirable? If the net present value is positive, it is desirable. If it is negative, it is not desirable. And why it is not desirable? Because the meaning of net present value being negative is the present value of the savings, so whatever savings you are going to get because of doing an energy investment, right? That savings would not recover the money. It would not recover the money which you have invested. That is C naught. Okay, if you are not getting the money which you are invested, then from the economic point of view, that option is not a good option to invest, right? So you see that net present value gives a very good idea about whether to invest or not in an energy conservation option. Now, finally, this term called as internal rate of return. Now, what is this internal rate of return? Again, let me take this example. You are invested, okay, you are invested some amount, C naught, okay, and you are getting some returns, let us say for 4 years. Let us say you are getting an amount A1 in first year, some A2 in second year, A3 in fourth year, or third year, and for the fourth year. Okay, now you are getting this, right? And in this case, you don't know what is the discount rate. This D is unknown. D is unknown. Now, if you want to get an idea about when will this investment break even? Okay, when will this investment break even? It means that when will your money be recovered? Okay, so from this chart, it becomes clear that your money would be recovered when this present value of this A1, A2, A3 and A4, present value of A1, A2 and A3 and A4 is equal to the initial investment. So when the initial investment becomes equal to present value of the savings, right, then the investment is viable. Okay, the investment is viable. So now at what discount rate, at what value of D will this equation be valid? Okay, so you'll have to solve this. So I have certain value A1 rupees, A2 rupees, A3 rupees, A4 rupees. I know how much I invested. Okay, now if I solve this equation, C0 is equal to PV, okay, C0 is equal to PV, then I will get the value of D. So that that discount rate, when my capital cost becomes equal to the present value, is called as internal rate of return. Right? So what is internal rate of return? Internal rate of return is the rate at which the capital which I had invested, okay, will fetch me the returns. Right? So at what rate I am going to get the returns for the investment I am making. So it is similar to the rate of interest which we get from the bank. Now, when you are investing certain money in the bank, you already know what is the internal rate of return because the bank tells you what is the internal rate of return. Okay, what is the rate of interest? So that rate of interest is the internal rate of return because the bank tells you beforehand. But when you are investing it in some business, okay, in that case, we don't know, okay, how much we are going to get, okay, or when will the money which I am investing would be recovered. So for that, we need to calculate the internal rate of return. So if the internal rate of return, for example, I get is 10%, and suppose the bank rate of interest is 8%, then I would say that this internal rate of return is fetching me more returns than the bank rate, and hence I should go for the option of energy savings. However, if the bank rate of interest is 8%, and if I am going to get only 4% internal rate of return, then I would say that this IRR is not a good IRR, because if instead of investing that money C0 in this energy audit option, if I had kept that money in the bank, that would have given me 8%. But now, because I'm investing it in this business, I'm getting only 4%. So this is not an economical proposition from the energy point of view. Okay, so these are the concepts which we generally used in economics. Before I end up, I need to underline the fact that economics is not the only thing on which basis we should take the decision. Okay, there are many important things. For example, if the energy which we are saving is not economically viable, but if it is going to do certain good, it is going to reduce global warming, it is going to reduce pollution, okay, or then though the rate of return is not good, still an investor would like to invest in that. Okay, so this economical concepts are useful. However, we should be very careful while using them. So when I'm planting a tree, for example, okay, or if I'm putting a solar water heater on my house, it might happen that you might get a simple payback period of 8 to 10 years. But still, it might be worthwhile, because if you are using a solar water heater, it is going to reduce the coal consumption, the coal which is going to be burned in the thermal power plant, and it might contribute positively to the environment. Okay, so not all the decisions are made on the basis of the concept which we are learning. So with this, I stop this. Hope you have enjoyed this. Thank you very much.